Okay, morning everyone. Hopefully we should be live. I'll just wait a minute or so just to check that everyone can hear me, and then we'll begin. To check everything's working fine. Okay, we're all good. Right, so firstly, I've given you the starter question. Make sure you've had a go at it. I've had a few responses to the quiz. I'll try and post that out a little bit earlier this time. It's really important that you do the start questions just to make sure that you've got the concepts here. So sometimes they'll be on things we've done recently. Sometimes there'll be things that we've not done for a while, which you'll see with tomorrow's question, which I'll post after this lesson. So with this question, the first thing that we notice is we haven't got the mean. So if you look at the mark scheme here, the first 3 marks is dedicated to actually finding the mean. So you know that... one second. There we go. Nearly forgot my lesson there. So firstly, we notice that we haven't got the mean, so we need to find that first. Now we look at the fact that we're given that 2.5% of the cut lengths exceed 50.98, and that would be, if you look at the mark scheme there, we've got 0.025. So when we are putting this in our calculator, what we need to do, so to get this 1.96 that they get here in the mark scheme, I'll show you how we do that. So we can't put in 0.025 because remember that's the area above 50.75. So what I'd actually have to put in is 1 minus 0.025 because I want the area to the left. I'd put in the standard deviation, which is 0.5. Sorry, because I need to do the standard values, I put standard deviation of 1 and the mean of 0. Okay, so I have to use the standard values here. When I do that, you can see there I get 1.9623 significant figures. Use the formula, so go back and have a look at the notes. I believe it's between pages 10 and 14 in Handbook 3. Have a look at notes there. Use that formula, x minus mu over sigma equals z, to get mu equals 50. Then for the last part, we can just use CD on our calculator. We've got a lower limit of 49, we've got an upper limit of 50.7. We want the probability that it's between the lengths that they give us in the question, and we use the actual standard deviation now, which is 0.5, and our mean that we've just calculated, which is 50, and we get 0.910. So that's how we do the first part to that. And then if we look at the second part, now you've got to do the hypothesis test. This is what we've been doing the last 2 days. So you have to put your hypothesis. So even if you didn't know what to do next, putting your hypotheses gets you at least 1 mark. Writing down your distribution and working out the probability, or noting that you've got to look for x being greater than 50.4, that will get you a 2nd mark. And then for that 3rd answer mark, you've got 2 choices how you could get this. Now you could either use the first method, which is what we looked at on Monday, where you work out the probability that x is greater than 50.4, which you find to be 0.0264. Now that is greater than your 1% significance level, so then you can conclude that there's insufficient evidence that the mean length of the strips is greater than 50.1. Alternatively, what you could do is what we did yesterday, which is find the critical region. So if you want to find the critical region, I've done a little sketch here to the right, and that's that if we have a 1% level of significance on our calculator, we do inverse normal. We're going to do an area of 1 minus 0.01, so 0.99. We've got a standard deviation of 0.6, and we've got a mean of 50.1. And you can see we get, that's not right. Of course, what I didn't do there, apologies for this, we didn't divide by the square root of n. So we need to do 0.6 divided by the square root of 15. Really important point there. And we get 50.46. So that is the value at which I reject. Anything above that, I reject H0. Now, you've got the mean was found to be 50.4. As you can see from my diagram here, that doesn't come within the critical region. So that's another way we can prove that we would be accepting H0 and saying that there's insufficient evidence. Right, on to today's task, but please do have a go at those questions before the lesson, and I can advise you as to what to do. From the people that I saw answer, I saw a lot of correct answers. I think the only one thing I'd pick up on is make sure you do the correct area. So some people working out less than rather than the probability it's greater than, so getting the answer 1 minus to being correct. Now what I want you to do today is ask us lots of questions. You can ask him in the S04 chat, so please ask away. It might be a question that someone else has as well. So we're moving into the S4 handbook probability. Now a lot of what we're doing today, it might seem familiar as to what you've done before, but there's a lot of notation and some slightly harder examples than you would have seen at GCSE. So let's go through them. Now firstly, we're talking about probability, and hopefully we all know by now, probability will lie between 0, which is impossible, and 1, which is certain. It is, it just means when you're doing calculations, if you get a number that's greater than 1, you know you've done something wrong somewhere. Now, these can be expressed as fractions or decimals. Sometimes you might use percentages. So all things that you're hopefully familiar with so far. Now, an experiment, just to go through a few definitions, an experiment might be something like, let's say, rolling a 6-sided dice. So that would be our experiment. The event is a collection of one or more possible outcomes. So, for example, this could be rolling a 6, this could be rolling an even number, this could be rolling an odd or prime number. So it could be more than one thing happening at the same time. And then sample space shows us all our outcomes. We also need to be aware of notation, and what you'll often see is things like this, where we write P and then bracket A, or P then bracket and then what the event is in words. So probability of A just means the probability that the event A happens, or probability of a club just means probability of selecting a club from a pack of cards. Let's get into the examples. So we've got 2 6-sided dice are thrown and their sum X is recorded. Draw the sample space showing all possible outcomes of this experiment. So I've done this already. This is our sample space. So you just write down all 36 outcomes that could happen. So obviously we get a 1 and a 1, we get 1 and 2, 1 and 3, or we get things like 4 and 6, and all those outcomes are down there. So there's 36 outcomes there altogether. And what I've written down is all the sums that they make. So this then helps me do part B, which is to find the probability of each event. So for the first one, the probability that X equals 6, there are 5 6s, so that goes on top of my fraction, and there are 36 possible outcomes altogether. So there's 5 ways that this event can happen out of 36 possible outcomes. Then when we get into the second one, probability that X is prime, so all I would do is just find all the places where I've got a prime number, count all the bits that I've shaded. There's 15 ways I can obtain a prime number when I roll 2 dice and add the numbers together. There's 36 possible outcomes altogether there, so it would just be 15 out of 36. And then finally, I've got the probability that X is between, x is 7 less than or equal to x, which is less than 10. Now, with normal distribution, you might have heard me say it doesn't matter about less than or equal to, or greater than or equal to. That's because when we do normal distribution, we're talking about continuous data. But here I've got discrete data. So this means for this inequality here, I include the 7, but I don't include 10. So what I do is just work out the probability that it could be 7, 8, or 9. So I count how many 7s I've got, how many 8s I've got, how many 9s I've got. That's 15 altogether. And then just divide it by 36 there at the end. Right, next, we're just going to look at some Venn diagrams. So in your handbook, there's a little bit more background about Venn diagrams. Yet again, hopefully it's just a reminder of something you see at GCSE. But I'm also going to start talking about some of the notation here. Now, firstly, we've just got our two circles, and it's really important that we draw the box around it. It's really important that we'll come on to later that we have these events that happen outside of these circles. Okay, but the circle for A just shows all the possibilities. Well, we'll break up the circle in a second, show what each part means. So if I'm looking at the probability of A, just anything that happens in this circle. So you've got two things here. Either A can be happening and B isn't happening, or A can happen as well as B happening. So that's the two sections we've got here. Then we have the probability of not A. And I can also write this as A with a little dash above it. That is just a shorthand way of saying that A isn't happening. So if I'm doing this, I can just shade in all the parts where A isn't happening. So one way to think of it is, well, if you look at the first example, where is A happening? And then just take that area out, okay, and then just look at all the other parts to it. We can also have probability of A and B. So this would be the intersection. Okay, so this is how we can draw it. So you need to get used to this notation here with that upside down U. That means both events happening at the same time. So what I'm going to do is I'm going to put a cross where A is happening. And I'm going to put a cross in a different colour where B is happening. Where both events are happening, this is where this condition is satisfied. So it's only these bits in the middle where the circles are overlapping is where I have the probability of A and B happening. What this means is both events must be happening. For example, where I've got the red cross that's not in the shaded bit, A is happening but B's not, so it doesn't meet the condition that both have to be happening. And then we have the probability that A or B happens, where we've got this U here, which we call the union of the two events. You might remember this from set notation earlier on. So yeah, again, I'm going to do a similar thing what I did in part C and put my crosses in. So I put the red crosses in for where A is happening, put the blue crosses in for where B is happening. But this time, because it's or, only one of the events has to happen for this condition to be satisfied. So either A happens or B happens, or A and B could be happening. So anywhere where I've got cross, I can shade in. So the only region that I don't shade in here is just outside of the circles, because that's where A and B both aren't happening. But in the first, where I've just got the one red cross, A is happening, B's not, so one of the conditions has been met. With the blue cross, B is happening, A is not, so one of the conditions has been met. And in the centre, both conditions have been met. So as long as you meet at least one, okay, it doesn't just have to be one, it has to be, in this case, just at least one, so one or two, then that condition is satisfied. So next example, we've got a card selected from at random from a normal pack of cards. Now, just to remind you, if you're not that familiar with cards. We've got 13 hearts in the pack and we have 4 kings. So on my Venn diagram, the first circle is going to be H for hearts and the second circle is going to be K for kings. Now I know there's 13 hearts in the pack, so that whole circle, each of the 2 sections, have to add up to 13. And the circle for K, for the kings, all of the circle has to add up to 4. Now, the other thing that I know about cards is there's only going to be 1 king of hearts. So in the centre, I just put a 1, and that's because there's only 1 king of hearts in the pack. Now, as I mentioned before, that heart circle has to add up to 13. So therefore, I need to put a 12 there. Okay, so don't just put 13. It needs to, the whole circle adds up to 13. So I'd split that up into 12 and 1. What the 12 represents is 12 hearts that are not kings. So this is the Ace of Hearts, 2 of Hearts, all the way up to the Queen of Hearts. And then in the centre, that 1 is just representing the King of Hearts. Then for the King circle, that circle has to add up to 4. So 1 plus 3 for 4. That 3 just means you've got your King of Diamonds, King of Clubs, and King of Spades. And that 1 in the centre, again, that's just your King of Diamonds. I'm not quite finished here. There's one really important thing that I have to put, and that's that, I've got 36 here. Now there's 52 cards in the pack. The numbers I've got so far add up to 16. So that means there's 36 cards that are neither hearts or kings. So it's really important that you put that number on the outside there, and also you enclose all of this in a rectangular box. Okay, so you will lose marks if you don't do that. So really important. So then we can use this to answer these questions. Find the probability that that card is a heart. So that will be, I shall do this to the side. The first one will just be 13 hearts out of 52 altogether. So that's just the probability of a quarter. Then we have the probability of a king. There's 4 kings out of 52 cards altogether. So that's 4 out of 52 or 1 out of 13. With probability, simplifying your fractions isn't as important as you would do normally in pure. But I'm just going to simplify them anyway. Sometimes you could be asked to simplify. And then we've got the King of Hearts. Well, we mentioned earlier, there's only 1 King of Hearts. So that's 1 out of 52. And then finally, a king or a heart that is not the King of Hearts. So we then need to think about how many cards that are kings or hearts that are not the King of Hearts. So we've got 15 of these cards out of 52 altogether. Okay, there's so we just count this 12 here and this 3. So we've got 15 cards that are either hearts or kings, but one of them is the King of Hearts, so we're going to exclude that one there. So just be 15 out of 52. So on to example 4. So we've got 30 students in the class, 14 are girls, so I'm going to call the first circle G for girls. 11 of the students have brown hair, so I'm going to use BR to represent brown hair. Of the students with brown hair, 6 are boys. So I want to do this as girls and brown hair. I don't want to do this as girls and boys, because then that's not telling me anything about the brown hair. Basically, we'll go on the assumption that if they are not a girl, then they are a boy. So I'm told that of the students with brown hair, 6 are boys. So there's nothing I can really do about the fact that 14 are girls at the moment, because I've got these 2 sections here, and I don't know how that's split up. And same with the brown hair at the moment, I've got this 11 here, I don't know how I'm splitting up that 11. But more specifically, of the students with brown hair, 6 are boys. So I know that this circle here needs the number 6. That's because in this section here, they have brown hair, but they are not girls, i.e. they are boys. So I just put a 6 here in the Venn diagram. The brown hair part needs to add up to 11, so I put a 5 there. So what this means is I've got 5 girls that have brown hair, and then the girls circle needs to add up to 14, so I just need to put a 9 here. Now remember, I'm not done here yet. All the numbers in the rectangle have to add up to 30. So I just simply add together what I've got so far and then take it away from 30. So the numbers I've got in the circle so far add up to 20. I need another 10. Now everything adds up to 30. For part B, a student is selected at random. Find the probability that they are a boy with brown hair. So a boy with brown hair, that's going to be 6 out of 30. And then I can just simplify that down to a 5th if I wish. And then for part C, now this actually kind of moves on a bit to conditional probability, which is what we're going to look at later on. And that's that we've got girls selected from the class. Find the probability that she has brown hair. So I'm not just talking about the whole class. I'm restricting this to only talk about the girls. Okay, so there's 14 girls altogether. So I'm just restricting it now because I've selected a girl. So I'm restricting this to 14 students, the 14 girls. Of these 14, 5 of these have brown hair. So that's what goes on top of my fraction. Example 5 is a nice and quick one. The survey's done to find out which of cats, dogs and gerbils people like. The diagram shows the proportion who like each animal. One person who completed the survey is chosen at random. Find the probability that this is a person who likes dogs or cats or both. So basically, as we saw earlier, that's just anything that's in the circle for cats or circle for dogs. They don't have to like both for this condition to be satisfied. But as we can see there in the brackets, we can include the probability that they like both. So simply all you need to do here is just add up all these numbers and we just get the probability of C or D is just 0.8. We could also just add the probability that they don't like cats or dogs and just do 1 take away 0.2 to get 0.8. And then we get to the last example, and this I think is a lot harder than some of the other examples. I know when we've done this question in the past, this is one that people struggle with. So we're going to take this nice and slowly and just go through this piece by piece. So we know that there are 60 students in a science tutor group. Each student takes at least one of the subjects biology, chemistry and physics. So first off, I'm going to put a 0 here to show that there is no student that doesn't do biology, chemistry or physics. And we're going to call this circle B, this circle C and this one P. We're also told only 5 students take all 3 subjects. So 5 goes at the centre of all of these. There are 22 students who take biology. Now at the moment there's not much I can do with that because I've got 3 other sections defined. I know the whole of the biology circle has to up to 22. There's not much I can do there with that at the moment. 7 who take biology and chemistry. This is what I'm also told. So for biology and chemistry, this is the overlap of students who take biology and chemistry. So I know that that section that I just shaded in, okay, I'll shade it in again, that bit has to add up to 7. So therefore I just need a 2. So I've got 2 plus 5 there. So that whole section adds up to 7. Now that section is split up into 2 people that take biology and chemistry but don't take physics, and 5 people who take biology and chemistry who do take physics. I'm also told 11 take biology and physics, so this part here has to add up to 11. Okay, these are people that take biology and physics, regardless of whether they take chemistry or not. That whole bit there that I've shaded in has to add up to 11. So I've got 5 there already, so now I need a 6. And what that represents, that 6 is 6 people take biology and physics, but they don't take chemistry. 5 people take biology and physics, but they do take chemistry. Now I can go back to the fact that there are 22 who take biology, so the whole biology circle has to add up to 22. So I need to put a 9 there to make that happen. So now if you add all those numbers up, they add up to 22. Then we're told that 25 take chemistry, 34 take physics. So I need to find these other 3 sections. I'm going to call them X, Y, and Z. And what I'm going to do is set up a few equations to help me do this. Now, so far, the numbers I've got there add up to 22. So there's 60 students altogether. So X plus Y plus Z must equal 38, because that's how many I've got remaining. Now, it's very hard to do that at the moment because there's 3 unknowns. So what I therefore need to do is look at the other piece of information that I've got. Now, I know that 25 take chemistry. So I know X plus Y must equal 25. Now, what I can do is go back to that first equation, X plus Y plus Z equals 38, and I can replace X plus Y with 25 now. And when I do that, let me just... Sorry, let me do the chemistry bit again. Sorry, no, made a little mistake there. With the chemistry, I can't forget about the 2 and 5 as well. So I've got the 2 and 5 there, so I've got 7 plus X plus Y equals 25. So I know that X plus Y equals 18. Okay, so remember the whole of the chemistry circle has to add up to 25, so the 2 and the 5, apologies for forgetting about that, that has to add up to 25. So I can now put X plus Y equals 18 into that first equation. So I've got 18 plus Z equals 38, Z equals 20. So then I've got physics, 34 there. So for physics, I know I've got 5 plus 6 plus Z, which I now know is 20. So I've got 31 plus Y must equal 34. So Y just equals 3. I can then go back and plug it in whichever equation I like. I can either plug it in the X plus Y equals 18, or I can put it in the X plus Y plus Z equals 38. And I'll then just get that X equals 15. So there are a number of ways you can do this last one. You can do it kind of some logical approach, or just do it with the algebra more if you want a more systematic approach. Okay, so what we should have here is the following Venn diagram. I'm going to put X, Y, and Z back in, and then I can just answer these questions. Now I've got the Venn diagram. These should be quite simple enough. The probability you find someone taking chemistry and physics. So you just look at where your chemistry and physics circles are overlapping. That is just simply here, where I've just shaded. So that's going to be 8 out of 60. Or if you like, 2 over 15. For part C, we've got only takes physics. So only taking physics, that's just this 20 people here, because they only take physics, they don't take biology and chemistry, so you can't include any of those other numbers. So it's just 20 over 60, which is a third. And then for part D, we've got biology or physics. So that's just going to be anything that I'm shading here. Basically, it just means that you just don't include the people that only take chemistry. So add all those numbers together, we get 45 out of 60, which is just 3/4. I can't see any questions in the chat, but please do ask whether you want to ask us individually. So you can do start a chat with us if you want, or put it on our S04 channel. It's good if you put it on the S04 channel because then everyone can chip in, and it might be a question that someone else had as well. We'll be back here tomorrow for the next part, which is mutually exclusive events and independent events. So that might be a bit newer. You might be not as familiar with this, but have a go with the questions that are to the right here. Make sure that you do self-mark. Show us that you're self-marking. And we're back here tomorrow at 11 o'clock.